Hello, I hope you're all having a good day. Today we're going to be looking at calculus. So what I'm going to cover is differentiating from first principles and differentiating by rules. So what is calculus? Well, it's attributed to these two guys, Isaac Newton and Gottfried Leibniz. And what they were basically doing was looking at graphs and trying to find tangents to different curves at a point, which doesn't make that much sense, but just stick with me and I'll try and make sense of it as we go on. So what Newton was doing was he was trying to find the area between 2 points underneath the curve. So say you take these 2 points, he's trying to find that purple area there. But what Leibniz was doing was trying to find the tangent to a curve at a point. So these are just two different types of the same thing. So then a beautiful bromance is born by them sharing the idea. That's not really what happened. They had a big argument over who thought of it first and started to hate each other, and this is an argument that's still fought about today. So yeah, they proper hate each other, but Newton didn't really throw an apple at Leibniz. But yeah. So the basic idea is that if you take 2 points on a curve and you bring them as close together as possible, then you'll get a better approximation of the tangent to the curve at that point. So this is the idea of differentiating from first principles. So bringing those 2 points as close together as possible. So yeah, this is where the idea of differentiating from first principles comes from. So if you take a curve and you plot a point x and a point x plus h, h is some very small constant, and you take the slope of that line, then the run of this is going to be h, because you're going to have x plus h minus x, and the rise of this is going to be f of x plus h minus f of x, because those are your y values. So then we want h to be as small as possible to get as good an approximation. So yeah, so this is the limit of h as h approaches 0. That's the notation we use, and the notation that we use for a derivative is dy dx, or f prime of x. So the derivative is the change in y with respect to x, so, which doesn't make sense to think about, but like, once again, just stick with me and we'll get more of it as we go along. So this is the rise over run as h approaches 0. So as that h value gets as small as possible, so our f of x minus h minus f of x all over h. So we're just going to take an example here of f of x is equal to 6x minus 3. So that's just some random function. So then stick in our f of x plus h, you get 6 of x plus h minus 3. So then when you take f of x plus h minus f of x, you're just going to have 6h plus 6x minus 6x minus 3 plus 3. So add like terms and you're just left with 6h. So then if you divide that by h, just finishing off the equation that we're given, you're just left with 6. You don't even need to worry about h approaching 0. In our next example, we will worry about h approaching 0. So the next example is 2x, f of x equal to 2x squared plus 3. So f of x plus h is 2x plus h squared plus 3. So then you just multiply out that bracket like you do any other square, and you get x squared plus 2xh plus h squared. So a squared plus 2ab plus b squared. And multiply all that out by 2, you get 2x squared plus 4xh plus 2h squared plus 3. So then you take away your initial f of x value minus 2x squared minus 3, and you add your like terms, and you're left with 4xh plus 2h squared. So then, as our equation says, you divide that f of x plus h minus f of x by h. So then you divide that by h, and you're left with 2h plus 4x. So then you find the limit of that as h approaches 0. So you just replace h with 0, so you have 2 by 0 plus 4x. This will leave you with 4x. So now differentiating by rules. We've got 4 rules. I do not suggest you try to learn them all at the same time. Addition, subtraction, product, quotient, and the chain rule. So now there are some rules to do with differentiating. Firstly, if you've got some function y equals a times x to the power of n, then the derivative of this dy dx is n times ax to the power of n minus 1, which just sounds complicated, looks confusing, but it's not really when you try it. So then if you got this function here, 4x cubed plus 2x squared minus x plus 7, then dy dx using that same rule, if you take our first term 4x cubed, you've got 3 times 4 x to the power of 2, because it's 3 minus 1. And then you just do that for each successive term. So you got 12x squared for the first term, then you're going to have 4 times 2 times x to the 1, which is 4x. Then you have minus 1, because you got 1 times x 1 times minus 1x, and then 0. That's our next rule, that the derivative of a constant is 0. Just think about this one. If you've got some function where y is equal to a constant of 7, then there is no change in y. It's not going up or down. Well, it's a bit curvy there, but in reality it's not. So there's no slope, so there's no change in y with respect to x. So our first one, addition slash subtraction. So this when you have multiple function of x, you've got f of x equal to ux plus or minus v of x. We just did this. Each of the terms in our last example was a function of x. So 4x cubed, that's a function of x. 2x squared, that was another function of x. You just differentiate each of them separately. You did the plus sign separating them, plus or minus sign. So then next question, find points on this curve where the slope of the tangent is 4. Okay, so I've just drawn a small graph there, and you want to find the points where the slope is 4. So we take the derivative of that function, you're left with 6x squared minus 2x. And then the idea of a derivative is that is the points in the curve where the slope is that. So you just set that derivative equal to your slope, then you bring it across and divide by 2 because we can, and we're left with some quite nice numbers. So we got 3x plus 2 times x minus 1 once you factor it, and then because of the rule of multiplication, if you've got two numbers that multiply to equal 0, one of them has to equal 0. So then you can say that 3x minus 2 is 3x is equal to minus 2, x equal to minus 2 over 3, or that x is equal to 1. So then we just take those values and plug them into our original formula to find the y values for the x values that we found. So y is equal to 80 over 27, or when you plug in 1, y is equal to 5. So our 2 points are x is equal to minus 2 over 3, y is equal to 80 over 27, or x is equal to 1, and y is equal to 5. So now we have the product rule. So this is when you have y is equal to u times v, where each of these are a function of x. So the rule for this is that dy dx equal to v du dx plus u dv dx, which once again looks complicated, but when you work with it for a bit, it's not that bad. So you've got the second term times the derivative of the first plus the first term times the derivative of the second. That's all it is. So let's say we got y equals x cubed minus 1 times 2x plus 1. So you take the second term times the derivative of the first. So 2x plus 1 is equal to 3x squared, using the same rules for derivatives as we have from the start, plus the first term times the derivative of the second. So the derivative of 2x plus 1 is just 2x. So, and then you multiply all that out, and you're left with 8x cubed plus 3x squared minus 2. That's all this is really. So let's say we got a slightly more complicated one. Y is equal to square root of x times 2x minus 1. Okay, so y is equal to x to the power of a half times 2x minus 1, because you know that the square root is to 2 times power, or to the power of a half. So you've got the second term times the derivative of the first plus first times the derivative of the second. So you've got a half of x, because that's the power, to the power of minus a half, because a half minus 1 is minus a half. So then you've got, just to look at that derivative of square root of x, you've got 1 over 2 root x. So then you're left with 2x minus 1 over 2 root x plus 2 root x over 1. So put them both over the same common denominator, and 2 root x times 2 root x is just 4x, which will leave you with 6x minus 1 over 2 root x. And now we have the quotient rule, where y is equal to u over v. So the rule for this is dy dx is v du dx minus u dv dx, all divided by v squared, which looks even more complicated, but once again, if you just work it out with words, it's easier. So you have the bottom times the derivative of the top, sorry, you can barely see that, minus the top times the derivative of the bottom, all divided by the bottom squared. Okay, so let's take, for example, y equals 2x cubed over 1 minus x squared. So you've got the bottom times the derivative of the top, so 1 minus x squared times 6x squared, minus the top times the derivative of the bottom, so minus 2x cubed times minus 2x, all divided by the bottom squared, 1 minus x squared squared. So then you just add like terms, and you leave it at the bottom as it is, so you're left with 6x squared minus 2x to the power of 4. That's all it is. So let's look at a real question example, and we'll be looking at if you've got y is equal to 3x plus 1 over 1 minus 2x to express dy dx in the form k over 1 minus 2x squared. Notice that the bottom's already in the form we need it in, so we don't even need to worry about that. Okay, so when you take the derivative of the bottom and multiply it by the bottom times the derivative of the top minus top times the derivative of the bottom, and then we're just going to So you got 1 minus 2x times 3 minus 3x plus 1 times minus 2. Add like terms and you find that k is equal to 5. Sorry, just interrupting the video here because I noticed something in the editing. The question asked for a constant k. So you immediately know there's going to be no x's, no variables in the answer because it's looking for just a constant. So you know that the x's are going to cancel out, which is just a hint for at the end when you're checking your answer. If you notice that your x's haven't cancelled, then you've probably done something wrong. You've probably done a sign error or something. I did myself when I was working it out the first time. Finally, we have the chain rule. So this is slightly more complicated to think about. So you got y is a function of u and u is a function of x, which doesn't make sense when you first look at it, because why would it? But basically, if you take an example, y is equal to x squared plus 3x cubed. All of that cubed. So u is what's inside the bracket. So we've got x squared plus 3x. So u is a function of x. Then y is a function of u. So y is what is outside the brackets, which is u cubed. So it's what's inside the brackets cubed. dy dx is dy du times du dx. It looks complicated, but it's what we've been doing the whole time. So it's the derivative of y with respect to u times the derivative of u with respect to x. So as we said earlier, y is equal to u cubed and u is equal to x squared plus 3x. Therefore dy du, derive it, and you've got 3u squared. Du dx is just 2x plus 3. So then multiply those together, you've got 3u squared times 2x plus 3. Replace u with the value for u we had earlier of x squared plus 3x squared. Then you just multiply it out, and it leaves you with a big number at the end, but it's all just straight multiplication from there. So you're left with 6x to the 5 plus 45x to the 4. Yeah. And then a question here, if you've got f of x equal to root 3x squared minus 2, find f prime of x when x is equal to 1. So as the example we had earlier, square root is equal to the power of a half, so y is equal to u to the power of a half, and u is equal to 3x squared minus 2. Then the derivative of y will be 1 half u to the power of minus half, which is what we had earlier. Du dx is 6x, because the derivative constant is 0. So you've got 1 over 2 root u is what that is equal to, times 6x. So then you multiply that out and divide by 2, and you're left with 3x over square root of 3x squared minus 2. So you just replace all your x's with 1's, and you're left with 3 over the square root of 1, which is just equal to 3. So you found your y when x is equal to 1. Thank you all so much for watching. If you want anything specific, just comment down below. I read it all. And if there's any questions, just throw them down below too, because I know it's a bit of a jumbled video, but there you go.